I'm now moving on to question number 5, and for question number 5, I still need to find the average value for part 1, and for part 2, I need to find all x values that attain the average value. Okay, so my function for question number 5 is y equals to e dx minus 1, and my domain is restricted to from 0 to ln 3. So I'm basically looking at this region right here. So if I look at all of these orange heights, I want to find the average of those heights for part 1. All right, so for average value, we know the formula is 1 over b minus a. Let's go ahead and label our a and our b values. So if I take a look at that, 1 over b minus a is going to be 1 over ln 3 minus 0 times the integral from a to b, which is from 0 to ln 3. And my function here is going to be e dx minus 1 times dx. So those are the numbers and the functions put into the average value formula, and then after that we can start evaluating this. So let's take a look at this part right here in green, 1 over ln 3 minus 0. That's simply going to be 1 over ln 3. And then if I take a look at this blue part right here, let's go ahead and find the antiderivative. So the antiderivative of e dx is going to be e dx. Actually, I will write this as a square bracket. Okay, so e dx minus, and the antiderivative of minus 1 is going to be just x, so minus x. Close that bracket off, and I'm going from 0 to ln 3. All right, so from here on, we're just using the fundamental theorem of calculus now. So 1 over ln 3, square bracket, and let's go ahead and use the upper bound here. So ln 3 there and there. So this will be e to the power of ln 3 minus ln 3, and then open bracket minus, and then another open bracket there. If I plug in my lower boundary now, this will be e to the 0. So e to the 0, we'll leave it as e to the 0 minus 0. And then I can close that bracket, and then another square bracket at the very end. All right, so now we've got to simplify this. This part right here, e to the power of ln 3. If I do that, if I simplify that, that just gives me 3 minus this ln 3. So minus, and then e to the 0 is going to be just 1. And then I can put a square bracket around this guy, and then I'll have a 1 over ln 3 in front. There's a few more things we can do to simplify this. So 3 minus 1 is going to be 2. So that's going to give me 2 minus ln 3. And then this part right here, the 1 over ln 3, I mean, we can definitely put the 1 over ln 3 in front like that. But basically you can just distribute that if you like, and if you distribute that, you would get 2 over ln 3 minus, and then 1 over ln 3 times ln 3, that's going to give you a value of 1. So 2 over ln 3 minus 1 is your final simplified answer for that particular problem. Okay, and if I go back to my original graph here, if I go ahead and just erase all this to create a little bit of space here, I guess if I did draw a horizontal line across, this would have a value of 2 over ln 3 minus 1, something like that. So let me just put that in my calculator and just see what that is. Actually, it's going to be a little bit lower, actually. It's going to be probably around here. So there's my average value of 2 divided by ln 3 minus 1. And then we have to find all the x values where we do have that y value of 2 divided by ln 3 minus 1. And from that point on, we just take our original function, which is e to the x minus 1, and we just make that equal to the average value, which was 2 over ln 3 minus 1. Okay, let me just erase that, and let's go ahead and solve this. This negative 1, if I bring it over and combine it with that negative 1, those negative 1s will cancel off. So I'm left with e to the x equals to 2 over ln 3. And in order to get rid of this e here, I can just ln both sides. So ln that and ln that. The lns will cancel off with the e's, and I'm left with just an x. So x would equal to ln of bracket 2 over ln 3. And that's your final x value. So if I had to go over here, I guess this x value here would be that one. So ln of 2 divided by ln 3. And that's how you do that last question there. Okay, let's move on. We're almost done this homework video guide. I think we have one more trig function and then a few calculator questions, and the calculator questions will be a little bit easier. Okay, so for question number 6, I got to find the average value again, and my function this time is the trig function sine x, and I'm going from 0 to pi. So my a value is 0, my b value is pi. So if I want to find my average value, I'll write that out as average value. And this is 1 over b minus a, which is going to be pi minus 0, times the integral from a to b, which is from 0 to pi. And my function here is going to be sine x times dx. And now we have to, do the algebra here to simplify this. 1 over pi minus 0, that's going to be 1 over pi. And if I look at this part right here, the integral from 0 to pi of sine x, well, the integral of sine x is going to be negative cos x, so negative cos x. And I'm going from 0 to pi. And then let's go ahead and use the fundamental theorem of calculus now, where I need to find my upper bound first. So my upper bound is pi, so let's plug that in there. So that's going to be negative cos of pi. Now, the fundamental theorem of calculus states that you need a minus sign, but when you plug in this 0 in for cos x, you get negative cos of 0. And if you have two negative signs here, then you should get a plus sign. So that's going to be a plus. And then in order to finish off this calculation, you can refer to the graph of cos x. So let me just give you a small little sketch of cos x right here. There's cos x, a very rough sketch. This is going to be pi right here. So when cos x has a x value of pi, the corresponding y height is going to be negative 1. So this part right here, cos of pi, is going to be negative 1. And then I have this minus sign there. That's going to be 1 over pi. Plus, and then if I take a look at cos of 0, well, cos of 0 has a height of 1 here. So cos of 0 is going to be 1, so plus 1 there. And then on the inside here, two negatives. That's going to be positive 1, plus 1 is going to be 2. So 2 times 1 over pi is going to be 2 over pi. So 2 over pi is my average value. And then you need to find the x values where we do have the y value of 2 over pi. And that's simply going to be just sine x, which was our original function, and we just make it equal to 2 over pi. So this is for the second part of the question, finding all the x values. And we can't find a very nice answer for this because this is not one of the special angles. So we can do sine inverse. Those guys and those guys cancel off. And you get sine inverse of 2 over pi, which you can put into your calculator. And if you do that, you would get 0.690. So that is one of the answers. And just remember, when you're dealing with the function sine x, let's go back to the original graph here. Here's the graph of sine x, and if I look at the average, remember the average value was 2 over pi, which is 0.6 something, and then this height right here is the average value, which is 2 over pi. And remember, we have two answers, one right here, which we just found, which was 0.690, and we have another one right there, right? So in order to find that one, we just do pi minus 0.690, and that would give us 2.451. So this is my other answer, and that's my first answer there. Now for this one right here, the 2.451, you can also think about this in using the four quadrants, because if you think about sine x, back in pre-calc 12, there is something called the four quadrant system, the CAST. And I know that sine x is positive in quadrants 1 and quadrants 2. And I know from here to here, our first answer was 0.690. And if I want to find this answer from here to here, basically you would do your pi. It would be pi minus 0.69, and that would give you the answer from here to here. So those are two other ways where you can find the answer of 2.451. You can look at the four quadrant systems, or you can look at the graph and just do it numerically as well from the graph. So if you're not sure how to get 2.451 after that, just come see me and then I'll further explain it in class. Okay, in order to finish off the rest of the questions, we just have a few calculator-based questions where we just put these into the calculator and let the calculator do all the heavy lifting for us. So the acceleration of a particle is given by this equation, and I want to find the average acceleration of the particle over the interval between 1 and 5. So this is a very clever way of just saying that this is your a value, that's your b value, and this is your function f of x. And if you want to find the average value, basically all the formulas that we've been using in this particular homework video guide is 1 over b minus a of a to b of f of x dx, and you're just plugging in the function and your a and b values into this. If I do that, I get 1 over 5 minus 1, and then I'm going from the integral of 1 to 5, and my function here is going to be 4t cubed minus 2t, and since I'm using the variable t, I will finish this off by saying d of t. And then all you're doing now is you're just taking this statement here and you can just plug that into a calculator, and if I do that correctly, you should get 150. So the average acceleration is going to be 150, probably meters per second squared if there were units. And that's it for that particular question. Okay, I think there's 2 more calculator-based questions, and then we can finish off. This time my velocity is given by this function, and I want to find the average velocity for this particle over the time interval 1 to 3. So this is your a value, this is your b value. So if I want to find average velocity, that's going to be 1 over b minus a. So b is going to be 3, a is going to be 1, so 1 divided by 3 minus 1. And then the integral from 1 to 3, and my function here is now 12t squared plus 1, and this will be dt. And after that, just plug that into your calculator and you should get 53 for this particular problem. So 53 is your average velocity, and that's it. Okay, and then the last one here, this one I need to find average acceleration. So the last question for this video is question number 2, part 2. And my velocity function was that, same one from the previous question, and my a value is 1 and my b value is 3. So this is a continuation from the previous problem. I know that my velocity function is 12t squared plus 1, so that means my acceleration function, I can find that by taking the derivative, so this will be 24t. And then this is the function that I'll be using for the average acceleration, which is what I'm trying to find now. So average acceleration equals to 1 over b minus a, which is 3 minus 1 on the denominator. Integral from 1 to 3, and this will be 24t, and this will be dt. And once you plug this into your calculator, you should get a final answer of 48. And that's how you can finish off that last question there.